Oh no. Don't worry, guys. We've got it worked out to where I can control this all from my side. Okay, thank you guys for joining. This is Nerdish. I am Brendan. Levi is tutoring a student online in his, well, office space, whatever. Actually in a room near me. And Brady is off tonight. So, you guys are stuck with me for a while. Sorry. I Crush Dreams. I was reading that for a while before the stream started when we had the thing running. For those of you who don't know, on Twitch he asked if we could teach them how to play poker. They're not good at it. And I really considered answering. And then I realized it's not what we're supposed to be teaching. I can't condone poker and gambling. But if it's just for fun, I have a friend who did some poker vlogging, right? I think I said that right. In college, and you should check him out. His name's Brandon Maddock. But, you know, you can check that out on YouTube. Anyway, enough promotion for my friends. Tonight we're going to be covering trigonometry basics, which I will be covering, and then later when Levi joins, he will be going over vocabulary and context. I would be doing that, but it's kind of a two-man job to run the overlay because new computer, and we don't have our pad working with the new desktop. It's Bluetooth, and it's some issues there. If you guys have any questions though at any time, let us know. Let's just jump into it. I'm going to assume, while I start this, that you have more or less no prior knowledge to trigonometry. And so I'm going to kind of start you in maybe a little too easy, but that's fine. If you guys have any questions or you want me to skip and move on to something a little more challenging, let me know. I want to start with the unit circle. This is where we get sine, cosine, tangent from. If you haven't heard of those, I hope you're not taking the test this Saturday. Okay, unit circle. That is a great circle. I don't want to ruin it. Okay, why do we call it the unit circle? What does that mean? We're going to assume the center is at the origin. And what we mean by the unit circle, what that really means is that the radius equals 1. One what, you might ask? I don't care. It doesn't matter. It's just one unit. All right, that's kind of the whole shtick there. So what we're, I guess some guy way back when wanted to figure out how you could, find a number of different values if I were to draw a line, a radius, right, like that, to some point on the edge of the circle. So what I can do is say, well, I know that this length is going to be 1 because it's a unit circle. So all of the radii I could draw in here is just going to equal 1, which is pretty convenient for what I'm going to end up solving for. However, what if I want to find the x value, right? Just the x portion of this line. So I could kind of drag a line down here, and right here, this is my x distance. Okay, just like if I were here, I could draw a line over, boom, that is my distance in the y direction. Now, what we're going to start with here is, I guess, a couple of things. So right here, this is the unit circle in its most basic form. Now, to be able to go into what I'm about to do, let's talk about SoHCA. You're going to be a little confused. Maybe you've heard this, maybe you haven't. So SoHCA has to do with trigonometric functions. So we have S being the sine, which there's actually an E at the end. The C being the cosine. I think there's also an E on the end. Otherwise, it would make sense to have sine and cosine, right? And then you have the tangent. All right? And the reason we remember SoHCA is because the sine, right, which would just be sine of x, right? When we write it, we have this. Cosine is just this, and tangent just this. All right, and x, we would have a measure of degrees in there. So sine is going to equal the opposite over the hypotenuse. The cosine is going to equal the adjacent, and I'll draw this on a triangle to make this a little more clear, over the hypotenuse. And tangent is actually O over A, opposite over the adjacent angle, or leg of the triangle. So ADJ. Let's use a different color. I was going to say better, but I actually like this green. It's a new marker. So if we have a triangle here, We know that this is the hypotenuse. And I don't actually know which one of these is opposite and adjacent because it depends on where your angle is, right? So wherever your angle is going to be, it's going to determine which one is opposite you and which one is adjacent to you. So if I had this angle here, then my adjacent is the one I'm touching. So this would then be adjacent. And this would be opposite. Why am I having issues writing? Whatever, opposite. However, that would change if I move the angle to the top. Then my adjacent would be here, and my opposite would be here. Pretty straightforward at this point. Now, the sine is going to be, if this were x degrees, I would say the sine of x is going to be my opposite over my hypotenuse, and I could get a numerical value, right? I'm going to take the opposite, which is going to be some number, right? Let's say this was a 3, 4, 5 triangle. Let's make it that. I would say 3, 4, 5, so the sine of x would be 4 over 5. Or something simple like that. So that is how you tie this together. It's how you imagine it and visualize this with triangles. Okay. Another way to think about this, if you've noticed, here I've actually drawn a triangle, right? I have a triangle here, or you can think of a triangle here. Either way, whichever one works for you, whichever one is more obvious. So I'm going to pull this out and extract a little bit. So now I have a triangle. This is this, and we know that this is 1 because it's the unit circle. So my hypotenuse, the radius, is just 1. My y value is here. My x value is here. All right? Now, if I wanted to, excuse me, find this value for x, I can actually think of this as the cosine of this angle. It's going to give me that value. And I will prove that. So let's say, let's do it here. So I have some angle here, theta. Doesn't matter what it is. It's just another variable that's not x and y. And if I want to find the sine of theta, sine would be opposite over hypotenuse. So sine of theta is opposite, so y over 1, because our hypotenuse is just 1. So the sine of theta is actually just equal to y in this case, because it's the unit circle. Right? The cosine follows the same pattern. Cosine of theta equals x over 1, so you get cosine of theta equals x, and my marker is dying. Let's switch over. From here, there's a couple of cool things you need to know, and that you can solve from this. Let's, for example, just do the Pythagorean theorem, right? It's a right triangle. So I know that x squared plus y squared equals 1 squared, or just 1. Now, this on its own seems pretty straightforward, especially since I told you that it's a right triangle. We've proven that the sine is the y, the cosine is the x. Again, not really too important here. If this is the x value, of course, that times whatever this y value is, or sorry, added to when they're both squared, is going to equal 1 squared. Right? You understand the Pythagorean theorem. That's very straightforward. But now let's do something that, because I've started with this, is not too much of a leap. But let's replace x with cosine theta. And let's replace y with sine theta. So what we end up with is the cosine squared of theta plus the sine squared of theta equals 1. This is a trig identity that you need to know. All right, so these basics we're covering, giving you, some of these I'll prove, some of them I won't go into as much detail, but this is something you need to know for the test. It comes up fairly often, whether it be in those last 10 to 15 questions. Are you teaching math? You're like, ha, 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 ha. Thank you. Yes, I'm teaching math. We're tutoring for the SAT and ACT. It's all free. Thank you, Aphroditesia. Aphroditesia? Or Aphrodite Sia, like the singer. But yes. Okay. This is probably the most basic trig identity, and we're going to get into a few more. So something you guys need to know that's clever. I do like the Greek mythology reference. That's impressive. Let's see. I want to keep up. Probably just that. So along with this, you might be wondering, how do you solve for angles, right? Let's say you don't have the lengths of the legs of the triangle, and someone wants you to find out the sine or cosine of some numerical value, some degree, and you don't have a calculator on you. First of all, shame on you, because you have a phone. Most of you probably have smartphones, and you can use that as a calculator. But, all right, let's assume maybe it's post-apocalyptic, and it's like the Book of Eli, where you have to pay a lot to get someone to charge your like old ratty iPod so you can listen to music. Oh, do you teach people that have dyscalculic? Don't know how to pronounce that. Similar to dyslexia. I have not. I would try, but I would also recommend they probably go to someone who has done that before. Also, I'm not sure how to say your name, so I'm just going to call you Sia, the last bit of it. Yeah, that's actually an interesting question. I do not think I am necessarily prepared to tutor someone who has extreme dyslexia or dyscalculia. That's clever. Okay. Back to what I was saying about these certain angles, right? So there are certain reference angles that you should know. Reference angles, okay? This is for sine and cosine. So I'll write cosine of theta and sine of theta. Now, the way I'm going to write this, it's going to have a pattern, and I like to teach it that way. It makes more sense. So you have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay? Should I know this for the SAT as well? Yes. Yes, encryption. There are certain things that they will tell you and give you on the SAT or ACT, vice versa, whatever, that you don't get on the other. But this topic is covered on both. I don't know. I'm interested in what the joke is going to be, Sia, but I'm not sure if I want the answer. Thank you. So the cosine, again, let's think about this. The cosine is the x value. So if I have a degree, an angle of 0 degrees, that means my line, it's just going to be a line here. Okay? Meaning this is going to be 1. It's going to be, if my y value is 0, my x value is everything, then it has to be the length of my radius. Same thing here if I have y, or my angle being 90 degrees, because then I am all the way up at the top, and my x value is 0, right? I'm at the, my x coordinate is 0. Thank you. Also, if you have actual math or English or verbal related questions, feel free to ask them, Sia. But thanks for tuning in. Same thing with my sine here at 90 degrees, right? I'm all the way up. It's the same length of my radius. My x value is 0, so that is going to give me 1. And if we think about this, what I just told you is that the y value here is 0 and the x value here is 0. What's going to happen here is these are going to mirror each other, which is really nifty. If you have trouble remembering this, it just kind of, well, you only have to really remember one. And really, the way I think about it, I only remember these, right? If you asked me on the spot what these were, I'd probably have trouble telling you what it is. I'd have to think about it. And that's fine, right? Because if you can prove it, then you're fine to be able to solve it. Now, ideally, if you're taking the ACT, it's a little more fast-paced, and you might want to know these very, very well so that you don't get, caught up on it on the test. But let's go ahead and look at 30 degrees. I know that as I progress through this, I can think about a way I'm actually adding value. So I know that this is going to be 1/2. And there's a number of ways we can prove that. And if you're taking the SAT, they actually, in a sense, prove this for you. The SAT proves, honestly, all of this that I'm about to show you for you. You just may not think of it that way. They give you kind of a cheat sheet for math at the beginning of each math section where they give you a lot of information. But I know that this is going to be 1/2, which if you were following what I said earlier, that means this is going to be 1/2, right? They are opposite each other. Now, the way I think about this, the way I remember, and you'll start to see it when I go with 45, and I'll prove 45, because 45 is really the key here to being able to solve for this. Hey, Neo-Socratic, good to see you. At 45 degrees, we have an isosceles triangle. Because at 45 degrees, you're half of 90. Right? So you have 90, 45, and 45. 45 degrees, 45 degrees. Right? Which means the angles opposite them are going to be, the legs opposite them are going to be the same length. So if I go back to Pythagorean theorem, let's make this 1. All right, and this x. Sure. At this point, I have x squared plus x squared equals 1 squared. Right? Or really, let's just say we don't know what it is, because we know that x squared plus x squared has to equal it. All right? Let's say it's an unknown value. That way we don't have to try to put in a numerical value for x. This will work always, right? We're going to generalize this so it works no matter what. This is going to actually equal, right? This is a question mark over here. This is going to be 2x squared equals some value squared. And I'll change this to a. We'll make it a squared. So a squared, all right? Then a over a equals, right? And we're going to square root this, x root 2, right? I can square root both sides. Let's make that show up a little better. And I end up with x root 2. Now think about it. At 45 degrees, I'm ending up with root 2 over 2. Because if I have an x and a y, both, root 2 over 2, I square those and add them together, I'm going to get this. Here we go. The way I like to think about this, and you can kind of see it, there is no actual, this is a visual pattern, and it's not how math works. So take what I'm about to tell you with a grain of salt. This is not how math works. I think about this as I'm incrementing whatever is on top by 1. So every value from 0 to 90 degrees is going to be the square root of some value x over 2. Why wouldn't the hypotenuse just be x? Because I started with x's as the legs, and so it can't be. So if I square x and I add them together using the Pythagorean theorem, I get x squared plus x squared. So 2x squared equals the square of the hypotenuse squared. So if I square root both of those, I'm going to get the square root of 2x squared, right? Which means I can't do anything with the 2. It's stuck there. So I still have the square root of 2, but I can pull the x squared out, and I get x. The hypotenuse could be x if I made this a different value. Yes. But the way I started it to make it simple on the front end is not going to end up with an x there, Neo-Socratic. Does this help answer that? Does that make more sense now? Please let me know. If not, I can go back through it. So leave this just for a second. I like to think about this. Yes, great. So, yo, Brandon Maddock, guys, for those of you watching, Brandon Maddock messaged on Facebook, Brandon, no joke, a kid at the beginning of the stream, hopefully you're still watching this, asked about how to play poker, and I pointed them to your YouTube vlog that you did, a number of years ago. So, hey, thanks for the shout out. Great. Dropping knowledge. I appreciate that. I think about this is, again, I have the square root of some value over 2, and I increase it, right? So at here I have 0 over root 2, or square root of 0 over 2, which is 0. I increment it to 1. The square root of 1 over 2 is still just 1 over 2, because the square root of 1 is 1. I increment it again, and I get the square root of 2 over 2. I increment it again, I get the square root of 3 over 2, and then I increment it one last time, I get the square root of 4 over 2, which is just 2 over 2, which is 1. Now, it's not, I mean, this is effectively what it looks like. And if you had an equation where you were just incrementing x, that's how this would work. But that is how I like to think about how to solve these. This is the only thing I have to remember. And I can remember it from 45 degrees. Because it's a value, the square root of a value over 2, and it's halfway, right? So 2, 3, 4, 2, 1, 0. I'm done. My memorization is just that. Okay. Man, I'm taking a lot of time on this. That's fine. You guys need to know this for the test. This is one, these types of questions, they'll ask you, like, what is the sine? You'll end up with, like, the sine of 30, and you might need to know that that's 1/2. Things like that is where this will show up. What's the last thing I want to do? We talked about SoHCA. There's one more identity, and then just because it shows up every once in a while on the ACT, I want to graph the sine and cosine function, or at least the sine function, just to show you what it looks like, so you're not thrown off when you see it on the actual test. Right? You're prepared for that if you're taking the test this Saturday and you see it Saturday. Again, any questions, let me know. Neo-Socratic, thank you for your question earlier. If you guys have questions that aren't related to this, we can just toss them up in the queue, and I'll be answering those in probably maybe 10 minutes. I don't think this will take too much longer. So continuing with what I just said, there's another kind of fun proof I want to go over. And this one, how do I want to do this? Yeah, I'm just going to have a regular right triangle. That's all I really care about. Can you cover the elements? No, you don't really need them. Thanks, Brandon. Can you cover the elements? Not really. It's not something you really need to know for the test. If you haven't taken it, the science section is really just reading graphs, and there are little bits, yes, of outside knowledge that are required. You saw them towards the end of the test in December. Was it something where you needed to have knowledge prior, or was it shown in the test? And what type of question, if you don't mind me asking, Neo? And I can put that up there and we can cover it a little bit. But from my experience with the test, unless it's something they just added in December, which is very possible, they don't really expect you to know much. They might expect you to know, solids, liquid, gases, but they wouldn't really expect you to know the density of hydrogen or something like that, or what the atomic value is. That's not really something they should expect of you. Okay. Now, not chemical elements? Oh, then maybe. Can you explain what you mean by elements then? Like 3 is an element of 2? What was the actual question? Because now I'm not sure what you're talking about. But let me know. So I'm going to cover this real quick. Neo-Socratic, let me know and I'll add it to the queue. For this one, let's say I have a value here that is just x degrees. And why not just make this y degrees? Okay? I know that a triangle has 180 degrees. So if I think about it, that's going to be 90 degrees is the right triangle, plus x degrees, plus y degrees. Everybody following so far? This makes sense. This is, all I'm saying is I'm describing this triangle for you, right? This is very basic. If you were to think about it, yeah, this makes sense. 90 degrees, x degrees, y degrees, they have to add up to be 180 or it's not a triangle. Great. Now, let's just get rid of the 90. So I can subtract 90, and I get 90 degrees equals x degrees plus y degrees. Again, on its own, this is not revolutionary. It's not really doing much for us. But it becomes quite interesting when I do this. If I were to just say, I want to solve for x. So x is going to equal 90 degrees, and I'm going to subtract the y over. So 90 minus y degrees. Now, again, I'm not doing anything you have not seen before. This is all very straightforward, very simple algebra 1. Great. Why did I do this though? Why does this matter? Well, let's say this is a 3, 4, 5 triangle. What is the sine of x? Well, x, the sine, is going to give me the opposite over the hypotenuse, so I'm going to get 4 over 5. Cool. Brendan, we've already gone over this. You're boring us. I know. But what if someone had asked instead, what is the cosine of 90 minus y? What if they just asked you this originally? That's a fairly confusing thing to try to look at. I don't know. I need to know why to solve for this. This is confusing. However, we've already shown that 90 degrees minus y equals x. So, oh man, I didn't want to do this, did I? I think I did. I did it wrong though. I want this to be an x. I want it to stay the same value, 90 minus x. So, the same way I did this, I can do it again, and I can say that y equals, or what is 90 minus x? I can go up here and say, well, 90 minus x is going to leave me with y. Boom. All right? Still following? So this is now what we want to plug in down there. I have 90 minus x, so the cosine of 90 minus x is really the cosine of y. So this is the cosine of y. And that's going to equal, now I have y, and I'm saying cosine, which is adjacent. I know that the adjacent angle or leg is 4, the hypotenuse is 5. I get 4 over 5. Wait a minute though, Brendan, that's the same values I have over here, and you're taking the cosine of one angle and the sine of the other angle. How does that work? It's really simple when you kind of take a step back and throw math out the window, which is not really a good thing for a tutor to say, but bear with me here. Take it out, throw it out the window, and say, okay, the cosine is what? The sine is what? We have it right here. The sine is the opposite. If I'm using x, the opposite, 4, over the hypotenuse, 5. Great. Okay, the sine, or the cosine then would be 3, the adjacent, over 5. Makes sense. But now if I switch, the sine is going to be 3/5, and the cosine is 4/5. So all we're saying is that because of this relationship we've been told, or we've already proven, right, the opposite over the hypotenuse, adjacent over hypotenuse, we know that if I switch these, or if I go from one angle to the next, my sine of one angle is going to be the same as my cosine at the other angle. And this is how we've proven it. This comes up quite often on tests where you're given, they will tell you, believe it or not, they will tell you the sine of x is 4/5. What is the cosine of 90 minus x? Well, if you've seen this before, you just write 4/5, you move on, and you're finished with the question in seconds. And it's great. They may, excuse me, they may ask something else about it, but that's usually how it's seen, and it's very straightforward. And if you have questions about it, if this is still confusing, let me know. But the way I like to think about it is just kind of course it makes sense now that I know what these stand for, that if I just say, think about it from this side, okay, and then I think about it from this side, what the cosine and sine are, yeah, they do end up being the same, always. So it makes sense that we can think of it this way. All right, yeah, I've got a couple more minutes, killing your guys' time here. Again, though, if you guys have questions, let me know. I'm going to erase all this real quick, so I may just kind of stall with my words. We're going to go into graphing these functions, and it may be something you've never seen before, which is fine. It's just something you want to at least have seen before the test this Saturday. You want to be comfortable with it. Neo-Socratic, have you thought of another example to what they had asked for the science section on the December ACT? Because I'm not quite sure what you're getting at. If you're talking about sets and an element in a set kind of thing, almost a math-related question, I can kind of go over that. I'm just not quite sure with the verbiage you've used, what verbiage, vocabulary, whatever, what exactly it is they were asking. Man, this spray. We've diluted it with water because it still works just as well, but then it takes longer to dry. Oh well. All right. Great. So back to graphing sine and cosine. It was subset, not element. Yeah, so you would say subsets. Sure, we'll say a subset. We'll talk about that. Subset and elements. Talking about an array, which, well, that's computer science jargon. Don't worry about that. So graphing it. So if I were to graph sine and cosine, or let's just do sine. So let's say this is the y value, this is the x value, and this is sine of x. Sine of theta, because I already have an x here. No, that's totally fine. It was B05 math. I don't know what you mean by that. So unless B05 is the name of the test, in which case I don't have that. Sorry, but I can give you an example of a subset and elements. So that's don't worry about it there. Normally we graph in radians. So pi radians is the same as equals, sorry, this is kind of vertical here, 180 degrees. So here's going to be pi, and here is 2 pi, and here is 3 pi over 4, and 1 pi, or pi over 2, right, just half. Same thing here, I'm not going to really write it out, but these are the negatives. So for sine of x, what does this equal? Well, using the unit circle, which I just erased, boo on me and my planning, but we know that our y value, so sine is the y value as we go along the outer perimeter. Still a good circle, then I ruined it. Although now it's just Super Smash Brothers. Am I right? Okay. As we go along the outer edge, we're going to say this is the y value at that angle, this is the y value at that angle or at that x value, right? But that angle, boom, and so on and so forth. So that is really what we're going to be graphing here, is our y value as we traverse the perimeter of the circle. So when theta is 0, we are right here. So we are at 0. And I like to think about this as, let's just go every quarter of the circle, every quarter turn. At 90 degrees, which is pi over 2, because pi is 180, so pi divided by 2 is 180 divided by 2, that's 90 degrees. And I'll even write it here, 0 or 2 pi. Pi over 2, that's an ugly pi. Don't tell him I said that, though. He's self-conscious. 3 pi over 4. Now, at pi over 2, I'm at 90 degrees, and we said that our y value is then 1. Say -1 down here. So, boom, I'm at 1. Great. Let's keep going. At this value, I am at 0. It's the same as 0 over here, 0 degrees or 2 pi degrees. I'm now at 0. As I continue, I'm going down, and now I'm also at what would be 1, but I'm in the negative direction here, so I'm at a -1. And I go back up, and I'm at 0 at 2 pi again. And now this isn't just harsh lines, it's actually a curve. And that's what it looks like. And so the reason I've only gone to 2 pi is because as the circle, just if you were to trace it, continues to go around and around the circle, this continues on like this forever. It goes the same way back here. Boom. There it is. Sorry, something popped up on my screen. I need to Okay, clear that. Okay. Hopefully this makes sense. If you have questions, we can get into this. We can talk about how you can stretch this graph and manipulate it. That's a little bit more complicated. But yeah, most of this, especially in the ACT, is very straightforward if you have your calculator and you know how to use it. All right. Now, Neo-Socratic, are you still here? If so, we're going to go ahead and jump into subsets and elements. And just kind of go over a quick overview of what they mean when they say that. Excuse me. For those of you who are new, we do this 5 nights a week. Normally, we do it Sunday to Thursday, but this week, great, you're here. This week, because the ACT is this Saturday, we're going to also be streaming Friday, Thursday, and Friday night. We're also going to be putting in extra hours, or at least Brady and Levi are. I am not going to be here Friday, but Thursday I will be here with them, also putting in a little bit extra time to kind of help you guys. We know that cramming is not the best way to study, but if that's the only time you guys are going to watch, we'll at least try to help you while you're here. We were students not very long ago, and we get how that goes. You procrastinate, and you don't realize you need to study till it's a little too late, which is why it's great if some of you are here now, but you know, ideally you were here months ago. Okay, let's get that. Okay, Neo-Socratic. Subsets and elements. I think this is a good marker. So first of all, a subset. To talk about a subset, let's talk about a set. So if I have a set, it's going to be a set of numbers, right? Or values, whatever. I don't care. Going through that phase. So a set would look like, you might have, I guess they might have a lot of different notation here, but in the long run, it's going to look like either this, 1, 3, 4, 7, or they might try to do it like this and do the same thing, 1, 3, 4, 7. It's whatever, same basic thing. Don't worry about it. Both of those are sets. Now, let's say this is a set. I could say that an element in this, so an element of set A, call this set A, equals one of these two, right? It's the same values, it's just a little bit different notation. Maybe that orange is good. An element of set A could be characterized by 1, 3, 4, or 7. Those are all elements of set A because they make it up. Any individual thing in there is an element of the set. I keep wanting to say array because a set is an array in computer science, and I did a lot of that, but if I mess up and say array, it's set. So you've been warned. So elements of set A, these are all the elements in set A. But what if I wanted a subset? So a subset is just going to be of set A, whatever. Of set A. Brady's going to have fun editing this. Subset is going to be just a couple of values. So it could be a subset. So it is a set within the set. That could be 1 and 7. It could be 1 and 4. It could be 3 and 4. And 7. It could be whatever, right? It cannot be all of them, or else it's just the set of A, right? You wouldn't really call it a subset if it was the entire thing. But that's really how this works. So your subset is a set of the set. So you're kind of narrowing it down even more. It's just a subset of it. Does that make sense, Neo-Socratic? Any questions on that? Does that maybe clear it up in terms of the question you saw in the December ACT? Any questions about this? Yeah. Boom. Done. And for those of you who are wondering, I know you were all, staying up late last night worried about this. I am feeling a little bit better. I'm not quite as sick. So what is it they want you to do? I don't know. I don't know the question, man. They might say, which one of these is a subset of A? And you have to say, well, all of these would be, but any value that is in here that is not there can't be a subset. It can only contain values that are in the first set. An element of set A is any individual value that is in that set. So I don't know what they want you to do because I don't know the question, and I can't pull up BO5, if that's the test name. Sorry. Like 3 is an element of 2 or something. I don't think that verbiage, that vocabulary is quite right. Unless it was of set 2, right? It's 3 in set 2 kind of thing. But that's really it. There's not much to it. I mean, you can get you can kind of get fancy with it. You think you got it? Good. If not, let me know. But it's not necessarily a difficult topic, or it's not a complicated topic. It's just you kind of got to look at it until it starts to fit together, like a puzzle piece and a puzzle. But once you kind of understand, okay, this is what a set is, this is how they represent it. A set could just be values that were recorded in a scientific observation, a scientific experiment. They said, okay, we had, I don't know, a whole bunch of kids at school, and they were eating lunch. Well, how many milks did the students buy? I don't know, guys. Did they buy 1 carton? We tested 4 students. 1 student got 1 carton of milk, 1 student got 3, 1 student one-upped them and got 4, and then 1 student went, way too far and they got 7 cartons of milk. Great. So then we can say, okay, well, what are the elements of set A? Well, 1 carton, 3 cartons, 4 cartons, 7 cartons. Right? And from here, you could take the mean, the median, the mode, all of that. You can do all of that on this, right? Any of those statistical analysis, whatever. But that's kind of the gist of it. Right? I want to look at the min and the max. So I'm looking at this subset of the students in the milk cartons they drink. I'm going to run with it. Yeah. I think I've over-explained. So we're good. Why is this leaking? I don't... All right, guys, if there are any other questions, let me know. Levi is still tutoring, and the vocab and context, I can explain it. I can, don't doubt me. But I would have to walk off screen to kind of change the screen to have the overlay on, and it's, then it ruins the magic if I disappear. Or is that part of the magic? I don't know, guys. You tell me. But yeah, if you have any questions, let me know. Anything, everything, SAT, ACT related, primarily ACT because that's the test we're covering, or we're trying to cover that a little bit more specifically because the test is this Saturday. But if no one's asking questions, I don't care to answer them. I mean, if most questions you ask from an SAT are also covering topics on the ACT, so it's not like that's going to be an issue. Also, unless it's a general question about or a very specific question about, hey, I have an issue with the reading section of the SAT and here's what I did. What do you think about the history passage? That I probably won't get too into today because, again, ACT is this Saturday. But anything you guys want, we can do. My back is hurting, so I'm just going to lean over a little bit. Don't mind me. Neo-Socratic, any other questions? trying to see. I don't know who else is on Twitch right now, so I can't really bother you guys, but I'd call you out. I'd say names. I'd name drop. Okay, well, for expected value is also something I had no idea how to do. All right. Ooh, can you go below? Can you go below? I think there's one below in the ACT, which is tagged below. If you want to scan through that, because if it's in there, I will pull it up. I'll walk off screen. I'll walk off screen and I'll pull it up. I can check to see if we have it, but I don't know. But I think an actual example will be better. I can go over kind of a more generalized way to do it. What's a good way to think about this in a simplified way? I like to think about it as like a weighted average almost. It's not quite the same. But they're saying like you have multiple different values. Sorry, checking the Discord. You have multiple different values, and you're saying, and they're weighted differently. So, let's see. Brady's gonna mess with that. I know it. Dang it. Your expected value. So if you were to roll, let's do a 4-sided dice. Roll a D4 for any of you who are also interlearning. A 4-sided die. Right? I think it's die because dice is plural. Someone correct me, but I'm pretty sure that's it. So you're rolling a 4-sided die. However, it's numbered 1, 2, 2, 3. Okay? I'm not having it, Ryan. They're towels to clean up with. I don't want to hear it, all right? Unless you're talking about the rash, in which case we don't need to talk about that. It's jokes, guys. It's Facebook. Okay, so expected value, Neo-Socratic. I'm going to give a kind of a short example here. But you have a 25% chance. So let's go ahead and say your roll and your chance. So I can roll 1, I can roll 2, I can roll 3. So if I roll a 1, what's my chance of getting that? I have a 25% chance of rolling a 1. And I have a 25% chance of rolling a 2. And if you're noticing, I chose a 4-sided die, not a 6-sided die, because I don't like working with sixths and repeating decimals. So I thought ahead. Great. Also, Ryan, thanks for tuning in. I appreciate you. At this point, right, I now have these 2 2s. So I actually have a 50% chance of rolling a 2. Well, what is my expected value? This is a really weird thing to ask for. I'm sure there's real use cases for it. I just think it's silly. But what you do is you take the value, right? We can call this the value, right? Same thing, but we can think of it as the value. And I'm going to say, well, I'm going to take my value and I'm going to multiply it by the percentage or the chance, right? So I'm going to multiply, and I'm going to end up with 0.25, 1, and, oh man, 3/4, 0.75. Right? Because this is 1/4. What I do then is I add them all. I believe I also, this is what I want to double check. Yeah, and I also divide. So, no, I don't. What is, yeah. No, I already took care of the division here. Yes. Now, I add these up. So my expected value is 2. So, sorry, let's make that a little more clear. I add them up, and so my expected value, if I roll this, my expected value is 2. Now, it's just conveniently what the largest percentage was, and that's not quite how this would work out if it was a larger set, or a larger set of numbers. See, we're going back to that. But this is how you do it. You say I have a 1 divided by 4 chance of getting this. I have a 2 divided by 4 chance, divided by 2 chance of getting this, and a 3 divided by 4. All right, a 1 out of 4, 1 out of 2, and a 1 out of 4, and I multiply it by the value, add them up. So my expected value is 2. Does that make sense? Also, did you find one in the ACT below? Because it'd probably be a better example than my very shoddily and quickly thrown together expected value answer. Expected value problem. Again, kind of similar to weighted average, but not quite. I'm getting sick. Guys, any questions, let me know. Expected value, that's a good one. Excuse me. Oh my gosh. Yeah, okay. No questions. Neo-Socratic, does that make sense? I'm not sure if you're still commenting here. Why is my... All right. You know what, guys? Okay. Great. Never mind. See, my phone's been messing up a little today, and I was just about to go on a rant, but it actually wasn't an issue. Yeah, you're looking for the question. Okay. But does this... I think there is, but I could be wrong. But does this make sense on its own? Right? This is a very simplified thing, but it's the process that matters. Right? If they say expected value, you're going to take the values and the chance of that value, multiply them for every value, and then add them all together, and that's the value you're going to end up with. This is actually a really clean number. Lots of times you'll get something that is not any of the values. So again, let's change these real quick. Let's change this and just say that I'm just going to choose some values to make this a little bit better. So I have boom, boom, boom. We're going to keep this here because it's still there. How do you do it quickly if there are many possible values? Excuse me. You still got to multiply them and add them together. It's not going to take too much time, especially on a calculator. It's just more knowing how to do it. So I think one of the tests was 2 die and 6 sides each. Yeah, they're going to give you the values of 2 to 12, right? And the odds of getting all of those. And you're just going to multiply it across and add them all. So it will take a little bit of time. And if you're short on time and it's an expected value, guess and move on, and then come back to it if you do have time, right? For any of these questions that you know will take you some time, forget it and move on. Let's say we have 3, let's make this an even number, 8 and 10, right? So if I had this, I would have 0.75 plus 4 plus, what is that, 2.25? No, 2.5, because I'm getting rid of the decimal, whatever. Now I add these together, and I end up with 6.5, 7.25. That's my expected value, which is really weird. That's none of my values. Why is that an expected value when I can't roll it? That's why I think this is kind of silly. But there you go. Sorry for anyone watching. Let's go ahead. Expected value. Screenshot of Brady. All right, cool. But it's more, yeah, these questions can take a good amount of time if there's multiple values. But it's more just, again, kind of recognizing what it is you have to do, knowing how to do it, and doing it, right? And again, if it's going to take some time and you're struggling with time, there's nothing wrong with guessing it, skipping it, and then coming back if you are either done with the others and you now have time to do it, or you have looked at a lot of the other ones, you aren't comfortable with them either. Well, okay, but you know you can get this one right, so let's go ahead and take a little bit of time, do it, and then continue on to some of those ones you're not as comfortable with. All right, for anyone joining, ask any questions you have. This is about the SAT and ACT, a little more specific to the ACT this week for the test coming up this Saturday. We can answer questions about really anything. I'm saying we because there's normally I'm not alone. That sounded really sad. Yeah. Any other questions, Neo-Socratic? Anything you want help with? I mean, right now, I don't see any other people asking many questions, so you're just kind of getting some free tutoring. Cheers to that. Also, I assume if these are the questions you're getting wrong, you're probably also doing fairly well on the math. Also, yo, Tyrese, Reese, thanks for the share. Thanks for the video share. That was a while ago. I don't know if you are still watching, but I appreciate you. Dang. All right. Yeah. Let me know, guys. I can cover anything. I can go over strategies. So in general, if you're running out of time on any of these, guess. Never leave your answer keys blank at all, because they don't take off points for guessing. and you'll miss every shot you don't take. Wayne Gretzky, Michael Scott, Brendan Duncan. So guess, and ideally you want to guess the same value for everything, right? That way statistically you're going to get a fourth of them right. Although ACT for the math, it's going to be out of 5, so you get 20%, but whatever, you get what I'm saying. Yeah, you're picking up what I'm laying down. Yeah, if you're not catching what I'm throwing, just let it drop. It's okay. You don't have to toss it back. Kachai? Any Chileans out there? Guess not. So, again, I just went over expected value. We talked about subsets and elements. I'm going to write that up and kind of cross it off so that if anyone's watching, they can see that we did it. And then, well, if they're just skipping through, expected value. Really weird question type, but it does come up. Anything else you guys want to talk about? Anything you want to learn? SAT, ACT, again, ACT is a little more pressing, if you will. If you have any more questions on the actual, what was I going to say? I lost it. I don't know, guys. I can pull up the test to talk about, actually, let me do this. I can pull up the test real quick. So I have a question, I have a problem I want to do for Trig, and it's a fairly basic question, so that's fine. Also, if you're watching, you haven't seen this. Whoa, the magic. All right. So we're working with question 30 real quick. Let me circle this. So the radius and the base of the right circular cone shown below is 5 inches, right? They label it for you. And the height of the cone is 7 inches. Again, they label it for you. Really, really handy here. Side note, if they ever are describing a shape or something for you like that in a question and they don't have it, draw it on the side. It's not going to take much time and it's going to help a lot, especially because most of math is visual. Plaster hippie. Yeah, you're right. But we'll get there. We'll get there. Yeah, this is not an overly difficult trig problem, but we didn't really talk about tangent much today, so I think it's a good example. Solving which of the following equations right here gives the measure of theta, right here, of the angle formed by the height of the cone and a radius. Well, remember we went over SoHCA, so I'll write it again. And you kind of can break it apart into these 3 boxes. So you have the sine, which is the opposite over the hypotenuse. You have the cosine, which is the adjacent over the hypotenuse, and the tangent, which is the opposite over the adjacent. And we didn't really talk about it too much earlier today, more than just the actual explanation of this. A plaster hippie has got it here. But how? All right, they want us to do what? They want us to find the angle right here, theta. Or they want us to find, what is it? The following equation which gives the measure of theta, all right, with the sides of the height and the radius. Well, that right there tells us everything we need to know. Formed by the height, boom, and the radius. That's possibly the best line I've done underlining because it's such a long section. For me, it's a long section, okay, guys? That is, I'm impressed with myself. If you're a new viewer, you just think I'm an idiot right now, and that's probably fine, and you might not be wrong. But what they're asking for is just the radius, boom, 5, and the height, which is 7. So we need to have 7 and 5 there. Those are the 2 legs we need to use. And you can see all of these right here. That was terrible. But all of those, and I'll erase it because that's a bad thing. All of them have 7 and 5 in it. So you know, okay. My friend sent me a funny text. I apologize. It's actually Brady. He's not here right now. He's on his day off. What a goon. He knows I'm streaming. All right. What a goofy goober. All of these have 5 and 7 in them. Great. So let's go back to the definition of SoHCA, or what we know about sine. Sine of this angle is going to be the opposite, 7. Okay, we're good. Over the hypotenuse. We don't know the hypotenuse. Sine is just out. It's gone. Number 29. Yes, Plaster Hippie, I can. Yes. Then we have cosine, which is the adjacent 5. Okay, we've got one of the legs over the hypotenuse. Okay, I can't use that either. So what we're left with, boom, boom, is the tangent. And the tangent is the opposite, which is 7, great, over 5, great. So what they do here to trick you is they have the tangent, which if you can do this and you cross it off and you forget what the TOA is for tangent, For SoHCA, you say, okay, I know it can't be sine or cosine because those both use the hypotenuse, and I need the radius and the height. You can at least use tangent. So you're down to 50% here. They give you both options so that hopefully, right, from their perspective, hopefully, you miss it. But you're watching this, so you know, and Plaster Hippie's already told you, that it's going to be the opposite over the adjacent. So the opposite leg is 7. The adjacent is 5. So the answer is G, the tangent of theta equals 7 over 5. Great. If there are any questions, again, let me know. I'm going to leave this pulled up. We're going to go over question 29. Plaster Hippie had a question. Plaster Hippie, are you not super familiar with imaginary numbers? What is the what tends to be a little bit more confusing for you? Let me know. Let me circle this. Do it. 29. How high up am I? Good enough. Okay. What is the product of the complex numbers negative 3i plus 4? Not super familiar with imaginary numbers. Great. I'm going to write this out and then I'm going to turn this off because all we really want is how to solve this. I don't have tons of room. But great. Also, if you want Plaster Hippie, we can kind of go into that in more detail, just imaginary numbers in general, but we'll just go ahead and do this problem. So we have negative 3i plus 4, and we're going to multiply that by, right, the product of, and that is 3i plus 4. Tell me if it's not 3i plus 4. I'm like 99% sure, but I could be reading it wrong. Also, speak now, forever hold your peace. I'm turning this off. That's right. Thank you, Plaster Hippie. Okay, this is what we're working with, and I can get rid of this. It's just kind of a floating circle at that point. Well, what do you think we do here, Plaster Hippie? I'm going to make this a little bigger here, but what do you think we do? Right? I mean, you've seen this before. Assume I is just x or any variable. Yeah, exactly. You FOIL it. Yes. So I'm going to go ahead and do that. And I'm going to get 3 times 3 is 9, but it's negative 3, so negative 9. I also have to multiply the I, so it's I squared. Whoops. Negative 3 times 4, so minus 12i. That's convenient. I also am going to have a plus 12i, and then I'm adding 16. So because we have, there's supposed to be a minus there, isn't there? Or is this a plus 4? If so, it should be, no, okay, yeah. No, I did it. I got in my own head. Don't worry, guys. Don't let that happen in the test. So these are going to cancel, and I'm left with negative 9i squared plus 16. Now, just to make sure I'm not crazy, negative, positive. Cool. Hopefully, Plaster Hippie, this is where you got, right? And maybe at this point, you realize this doesn't match any of the answers. Or it shouldn't. I would hope not. You can simplify it more. So if they did this and gave you the simplified version, I'd be upset. Unless they said specifically to simplify it as much as possible, which is not really kind of how they ask these questions. So, hopefully you were able to get to this point. You knew to FOIL it, right? You're pretty comfortable with FOILing. Now, what is I, right? Because I is going to determine what I can do here. If you don't know, I equals the square root of negative 1. Good, you got here. So let's think about this. Well, what is I squared? That's going to be I times I. Or let's keep breaking this down. The square root of negative 1 times the square root of negative 1. Or I can also write this as negative 1, the square root of negative 1, squared. So I just get negative 1. Right? Meaning I can substitute, or I should substitute, negative 1 for I squared. So I now have negative 9 times negative 1 plus 16, or 9 plus 16, or 25. Does that make sense? Also, if you're not comfortable with i's, I can go over something else that is pretty likely to show up. And I think it's one of the last questions on this test as well. But let me know if this makes sense. If not, I'm going to check out this test real quick. I want to see something. Thanks. Awesome. So, come on. Let me... I don't think it's the one I wanted. Nah, it's not. That's okay. Let's go one more back. Is it here? No, it's not. Okay, that's fine. So those are tricky. Yeah, I hate the I to the 10th. Okay, great. That's the one I wanted to go over. in the 50s of the ACT. Yes. So, what a goof. Great. Not you, my roommate. Those are tricky. Let me simplify it for you. Let me make this very, very simple. So first of all, there's only a couple of values that it'll ever be. I to the power of something is only going to give you one of 4 values. So simple enough, right? Or maybe it sounds simple, but you're like, well, yeah, I mean, they only give me 4 values, but okay. I just wrote down what I was and what I squared was, so I'm not going to go through kind of solving those again. I'm just going to write it back up. Life lessons. Yo, Tim, what's up, man? It's been so long. Hope you're doing good. Hope you're doing well. Teaching grammar, teaching SAT and ACT prep. But good to see you, man. Hope things are going well. So i's to certain power. So I, we said, is the square root of -1. I squared, we said, was -1 because we squared this. So what would I cubed be? And also I to the 4th. Go ahead, Plaster Hippie, and anyone else who's watching and has some issues with imaginaries. Go ahead and try to give me this value, and I'll go ahead and walk through this. All right? So I cubed is just going to be -1 times I, right? Because it's I squared times another I. So that's just -I. Okay? If that doesn't make sense, let me know. I'm just going to rewrite it here to save some space. Keep it less cluttered. -I. And then I go ahead and plug that in, -I times I. And we kind of already went over this. That's -1, but it's a -1, right? I end up with -1 if I have positive values. I add that negative in, and I get a +1. So far, Plaster Hippie, does this make sense? Just these 4. Yes, it just rotates through these 4. You're right, because I to the 5th, I to the 6th, right, and so on. Good. So what you want to do then is take I to the 198th, and you want to divide it by 4. You want to take 198, divide it by 4, and you're going to get, what is that, 29? No. That's foolish. 49. 4 times 4, 60, yeah. 49, which is going to give you 196. You can get 2, right? So you get a remainder of 2. Yeah. So all you care about, though, is this. This is the money maker, if you will. Okay? I don't care about the rest of this. I care about the remainder. What I do with that remainder, plug it in. So that is now I squared, or -1. Same thing. That is how you do those questions. You will never again be fooled by something that is much simpler than it first appears. Simple not meaning it's not challenging or difficult. It's just simple meaning that if you understand the topic, this right here is simple division, and that is simple. The concept can be quite difficult, but the actual math involved may be very, very straightforward. Not trying to, belittle it at all. I would say you should understand how to get them. And after you do it a couple of times, it starts to make sense. You kind of start to have it memorized. But I would say it's much better to just memorize, if you will, this. Memorize this, and then you can solve everything after that. It's right. Square that, okay. Multiply that by I, okay. Multiply that by I, and you get something that is -I with a negative, or -1 with a negative, and it's a +1. I think as long as you I don't like saying memorize, and I hated when my teachers say that, and now I'm spewing this garbage. But don't memorize. But I will say you should memorize that. And it's not going to be a problem if you memorize the rest of this. Absolutely not. But I'm saying if you're short on time for Saturday and you're just trying to remember the most important things, this right here is the most important thing to remember with imaginary numbers. While we're on this... Dope. While we're on this, though, I want to go to another type of question with imaginaries that maybe you haven't seen, that is also possible or likely to show up on the test this Saturday. Because I is a radical, right? If there's a square root, you can't have it in the denominator. You can't, right? Your teachers always tell you, no radicals in the denominator. It's irrational. It's an irrational number. Not that it's irrational to do it, per se. That's kind of a philosophical issue. We won't get into it. That's not what we cover on this. So, I'm going to write this again. Square root of negative 1. What if I had 5 over, let's do 5i plus 2. Let's make it a little bit gross. Over 3i plus 4. What would I do? What could I do? What do I do with this? Well, you can't leave it in the denominator, right? You can't leave this I there because it's a square root. So you can't leave it there. You're not allowed to. Plaster Hippie, do you know how to approach this? If not, I'd love to continue. And if there's any other viewers, multiply denominator to top and bottom. Not quite. You're close. We want the complex conjugate is what it's called, but I don't. So you're very close. You're on the right track. So Plaster Hippie, you said to do 3i plus 4 and 3i plus 4. Yes, exactly. We want it to be negative. And the reason we want to do that is because, and I'll do both, right? So I'll do minus, but let's do 3i plus 4 and 3i plus 4 real quick. Because it seems like the right thing to do. So I just want to walk you through it and show you why it's not going to work out how we want it to, and why it would just cause another issue. So 9i squared, right, plus 12i plus 12i plus 16. I'm going to get negative 9 plus 24i plus 16, or I'm going to get, what is that, 7 plus 24i. And then I still have an I in the denominator, and I'm not done. And I've made the top a little bit more complicated. So this is why we use the complex conjugate, right? Because using the negative, the conjugate here, it eliminates these two values. These two values end up being exactly the opposite one another, and they cancel, meaning we would not have this value at all. Does that make sense, Plaster Hippie? So what I'm going to do here, and I'll do the top first. So I have 15i squared plus minus 20i. Oh no. Minus 20i plus 6i minus 8. All right, that's on top. It does make sense. Great. That's my numerator. My denominator, though, is going to be 9i squared. Hey, Levi.
Hey, Plaster Hippie. Hey.
Minus 12i plus 12i, right? Minus 16. So again, like I said, it's going to allow us to cancel these two values. Let's go ahead and clean up all this. So I have 15, so negative 15 minus 14i minus 8 over negative 9 minus 16. Minus 16. And to simplify that even more, we end up with, what is this? 15, 23, negative 23 minus 14i and over negative 25. There you go. So this is something you don't want to forget with imaginaries either. How'd it go, Levi?
Well, good. Well.
There it is. I squared should still be with 15. I made it negative. Yeah, sorry. So from here to here, I went I squared equals negative 1, and I plugged it in. Yep. No, you're good.
Plaster Hippie, it's good to see you. Haven't seen you in a while.
Asking a good amount of questions, too.
Actually, technically never seen you, but I've seen your name many times.
There it is.
I see you, like the metaphorical seeing of another.
Is it oh, can you go get the door?
I hear bumbling around.
I'm not happy that he asked that.
It's fine.
I guess, yeah, no, because if there was more than one of us, it would have been fine. That is true. That is very true. Hey, well, thank you. Thanks.
Actually, you haven't missed anything. We actually didn't stream since... When was the last time we haven't streamed since then.
Nah, we did take off for almost all of December, though, because of travels and holidays.
Yes.
Like hollandaise sauce, where it's kind of like an egg yolk.
Hollandaise sauce.
Yeah.
Plaster Hippie, I'm sure that you... Well, did Plaster Hippie ask any Brendan's personal life questions?
No.
Or no?
And that's for the best.
Yeah, might be for the best.
They had real questions to ask.
That's good.
They also are pretty good on their trig basics.
Ooh, 1280. Solid.
Nice.
Very solid. Trying the ACT now. Not a bad idea. 28. I'm going to check my conversion table.
28's better. hold on, it's every 30 to 40, so it's every 100 is 3, so 200, 6. No, that's better.
ACT is better?
Yeah.
I don't know.
And they are both good, yes.
I have 4
Encryption's
favorite photos.
Because it's 1100 or 1080 to 1100 is about a 21, if I remember right.
28 is better. Yep.
Mm.
Nice.
Well, is 1100 about 21?
1100.
Because that's like my reference.
That's your reference?
Yeah.
1100. No, 1100 is 22. The bottom of 22.
Oh, okay. So what, like a 1080, 1090?
Yeah.
All right. No, that's fine. So yeah, that would be a 27. A low 27 would be a 1280. So yeah, you're possibly better at the ACT because it's better.
Okay. So, encryption's here. High encryption.
Yeah. Had some people from Facebook posting, commenting, some friends of mine. We had a friend of mine, worked at the restaurant when we share it.
Nice.
Yeah.
Very nice.
And Brady sent me a message while I was streaming.
That's fine.
Although it's very relevant to our conversation we were having the other day, which was how smoking should be illegal, or it should be an actionable offense. Like, because if you, like, secondhand smoke is very dangerous, and smoking in general is something that can cause others harm. So I'm not allowed to go around hitting people with baseball bats, but you're allowed to go smoking around them. So
one is a little bit more aggressive.
Yeah, smoking. Guess how many people die from baseball bats a year? Probably not 40,000 in the U.S.
That's
just an assumption. Just an assumption of mine, but I'm going to say it's probably less.
Yeah.
But Hawaii is proposing a new bill, which I think is amazing, that the legal smoking age, ready for this? 100. I hope it's not an Onion article. I didn't actually read it, but the Washington Post. Hawaii proposed a new minimum smoking age. 100. Let's go. Lung problems? Honestly, quite a lot. Quite a lot. We don't need to get political here, but so much more than anything else you can think of. Except for maybe heart disease, which can be caused by this. So, I mean, whatever. This is just saying.
I'm making these numbers up. I saw that article on Reddit. Oh, there you go.
Oh, nice. I haven't been on Reddit. Almost did all today. I'm pretty upset with myself.
Wow. Oh, sorry.
Yeah, thanks. Oh, high five?
Yes. I think we did well there, huh?
Smart lot. I think so. I just don't... Look, maybe it's because I don't smoke, but I just don't think it should be allowed.
You should, and by they, I mean them.
Smoking can
They
kill.
should do smart laws. You know how they're like smart homes, and there should be smart laws. That's amazing.
What would that be?
I have no idea.
Everything that is a smart thing is a physical device that connects to the internet to make it smart.
Right.
You can't have a physical law.
Yes,
unless I get to walk around being the physical law. Police officers that are androids, I get it. Okay.
Yes, exactly.
They'll test you.
Oh, RoboCop exists.
Oh, dang it.
Dang it.
No officers will enforce the law. You know what? No. I would go and be a cop just to enforce it. What do you think about smoking on one's private property? Go for it. I mean, if you want to do that, I don't care. But not around children. Not around young children who don't have the option to not be there. This is my personal belief. I don't know who else believes it. That's fine. This is Nerdish's stance, although I would argue it should be. No, if you want to do it in your own home, go for it. Go for it.
You are the one who always says no politics.
I don't think this is politics. This isn't something that is in politics. This is something that both sides are like, hey, give us the money. We'll take it. I don't care.
Sure.
Right? It's not my problem. I hate the government there. This is a social issue. Right. It started dropping off, and now people are thinking it's cool again. I don't know, man. I'm not about it. I don't care what you do in the privacy of your own home. As long as you're not harming children who don't have the option to not be there. Right? That should be pretty straightforward. Probability of smoking. Too high.
Is that too high?
No,
I
that's
see what
low.
you're saying.
That's low, to be honest. If we're doing U.S., I still think that's low.
We are doing a sample. Of some
sample size.
It is very representative of some group. Just don't know.
Subscore section. Any tips on the science section? Yes, and you may already know this, but you don't want to read the section. And I don't mean you don't want to read it first. You just don't want to read it.
That's assuming they want to do well.
Yeah, if you want to do well. But what you want to do is read the questions first, and they'll say, hey, look at figure 1. And you'll say, oh, figure 1 is a graph. I almost went into that accent I did last time I did this when they clipped it. Figure 1. But you want to, so you always skip the section, and no.
You upset him.
So you don't skim it. Don't read it. Don't skim it. Don't do nothing with it.
Well, you could look at it to figure out which passage type it is, but it's not.
Sure. Yeah, you can give it a glance, a one over, to know what type of section you're dealing with. Don't skim it. No.
You know, I don't even
skim it.
I like that voice. I don't like being alone with you or Brady doing that voice. It makes me feel very...
No. Okay, Pastor Hippie, you got the right idea, okay? Man, I'm sick and this doesn't sound as good as it should. Yes, you definitely want to save the conflicting viewpoints for last. You don't want to skim anything. Don't look at the charts because you don't know why you're looking at them. So just don't. You can get comfortable with them or used to them after you find out why you need to look at them. Sometimes there might be graphs you don't need to know about. Don't waste your time. All your time should be used very effectively. So what that means is you read the questions before you look at it. Before you look at it, unless, I mean, yeah, sure, you can glance to make sure there's a graph so you don't do the conflicting viewpoints until it's the last one, right? Whatever. Save it for last. But you want to read the questions and only go where they point you. Now, you will end up reading some of those graphs, and you might even end up reading some of the sections, and that's fine. That's fine. But don't do it first. Don't do it at all. I look at the graphs for trends generally. No. I think that's a good way to look at it after they tell you to look for it. Otherwise, you're wasting time because you're going to have to go and look at it later. If I told you there was a buried treasure, and just that, are you going to go and start digging holes in your backyard? No, you're going to wait for me to tell you where the buried treasure is. And then you're going to be, oh, X marks the spot. And it's a lot of saved time. I don't know if that's a horrible analogy or not, but I like it, so I'm running with it. You have the right idea. Exactly. Okay, so it did make sense. Good. It worked. Yeah, that will help you, I would say immensely, but it seems like you kind of already aren't spending too much time on it, but it will definitely help you if you don't waste any time skimming or looking at it. Do 26%. Oh.
Where? What are we saying? For which percent encryption?
But yeah, Plaster Hippie, if there's anything you learned from tonight, don't you dare read up here. Don't you dare read. No, do read this, but don't you dare read the science section or even skim it unless that specific question you're working on tells you to. Otherwise, you're wasting time. And time is everything for the ACT. You'll thank me. Also, do a science section with that method, that tactic, that strategy, if you will, before Saturday, and tell me if it doesn't help. Do it. Tell me. Try it. Tell me if it doesn't. Okay.
So encryption. Who?
13 minutes.
Yes, very good.
Justine, is she here?
No. Soon. Okay. So I can't put 26 up there because the little words
come
here
back
matter.
And let me know. Oh, I won't be here. They'll know. Tell them.
Very
Tell
good.
them.
Okay. So the probability of finding... So we're just taking a human being out of New York. Yeah? So we're I have no idea.
With those small percentages.
I have no idea. Yeah, no, it's probably decent.
Have you walked... You have not walked in the streets during noon.
True.
Too many people smoke.
Okay.
But one person smoking is too many, but so many people smoke.
Such confirmation bias. You're outside. You're like outside buildings at noon. Of course there are people smoking at that time.
Yeah, but there's a lot of people smoking.
Anyway,
you haven't even lived in the city, really. I don't want to hear from you.
Stop your semantics and your pedantics.
Maybe, but not semantics.
Okay, anyway. The probability of picking a smoker randomly out of this group of people is 17%. The probability of picking out a smoker who has lung problems is 11%. Okay, so it's both. That's why I can't say...
Which, if we think about this, that's a large percentage of smokers.
Yeah, it's a large percentage of smokers. So that's actually what we're trying to figure out.
Oh.
We're trying to figure out the probability...
My bad.
I mean, you won't actually know what it is.
That's true.
So we can't make this 26% because that means that more people have lung problems and smoke than just smoke, so that makes no sense. That's why I didn't take that 26%. And I also changed that. Now, we are looking for the probability of lung problems given that the person is a smoker.
So we need to know the population size. I want to know.
Well, so it's just probability.
I know.
Yeah, and I made all of this up.
I want a number.
So, the way we're going to write this...
Well, you said New York, that's 8 million.
I'll be...
Do you want me? No, let me go. No, let me go do it. Let me go do it.
Okay.
Oh, man.
Hey, Brendan is getting you. He'll be there in like 2 seconds.
Also...
Go.
Hey, Jenna.
You have to go. It's fine. Don't be scared. Don't be scared. It'll be good. Yeah. Okay. No, it's not bird. Very sorry. So the probability of, what are we looking for? Lung problems. Problems. I'm going to write this line here. That's what that signifies, given. Given that we have a smoker. Okay? Now, the way we have to do this, this is very hard. This is about as hard as Algebra 2 gets. This is about as hard as probability gets, or significantly harder. Still what?
Alive, breathing.
Good.
I think it got a little bit colder out.
So here, we're going to have to figure this out, and this is very tricky.
I'm not Brady.
It's very tricky. Yeah, they were hoping it was Brady who was getting here. That's good. That's positive. Not you. No, before. As soon as you left, they said, "Is that Brady that Brendan's getting?"
No, it's not.
No, it's
He's
okay.
busy doing stuff,
Now,
being a human and an adult.
This is not as simple as it may seem right away, because we're going to put this in a bigger equation. We're going to say that this equals the probability of both of these things happening at the same time. So this is, we're going to write as lung and, this means and, lung and smoke. Okay? Now these don't equal each other necessarily. This is lung problems given that we know they're a smoker. This one is saying what is the probability that they are both. Now we know what it is. It's 11%. But these don't equal each other yet. What you have to do is you have to say this one times, I'm going to multiply this one by the probability of smoker. Okay? Can you give me another yellow? This is horrifying. Thank you.
Yep.
Beautiful.
I know.
Oh my gosh, very.
You know, it's a really good one.
So smooth. Wow. I'll give it back to you.
Yeah, thanks.
I'm not going to use this one.
Okay. Well, you let me know where you're going to be walking back and forth, so I'm not in the way.
So so this is the probability that you get someone that 11% is going to be. Let's assume that let's get the probability that you choose a smoker, and then given that you have a smoker, you need to see the probability that they also have lung problems. So that's where this equation comes from. I hope that makes sense. That's hard. That's hard.
I don't know if they get into it this much in the ACC.
No, but we're over now. Nobody's asking questions. And I just was teaching this. And
I know you were just teaching it, but they could have had actual questions. That were
hey, if you have questions aside from is that Brady, then
hey, Chesky. Good to see you. Are you new?
Are you new?
Maybe.
Ooh.
Are you from Drumsy? Are you from Reddit?
Were you born yesterday?
I hope not. There's an age restriction for Twitch. Isn't it like 13?
Yes, but not for the SAT.
Oh, hey. They know each other. Also, wait a minute.
Thank you for the follow.
Hey, thanks for the follow. Chesky.
Very nice.
Sky, I would say. If it's anyway.
I don't know.
Well, because they know each other and they use real names.
Okay.
But we won't.
Yes. So I hope this makes sense. It's the probability of both things happening at the same time. And the way you find that out is you take probability of one of those things happening times the probability that causes the second thing to happen.
Oh.
Now, we are solving for this piece right here. We don't know that one. But we do know the probability of smoking.
They're already speaking. They were born
which
today.
is 17%. Oh my god.
You can already type. It's
Wow.
what you know what
That's
they're saying.
What's gonna happen
well,
now.
yeah, you know what they're saying about kids nowadays. They can use technology so well. They're literally coming out of the womb using technology.
Smart kids.
They're smart. I hate you. I walked into it.
Yes, you did.
I wasn't ready.
You did.
That's upsetting.
Probability of smoking is 17%, so we're going to do 0.17. Then we're going to just have this one, so I'll leave it there, times this thing. And then we have that equal to probability of that, which is 11.
Yeah.
That's Spanish for once. Now we have
How
this.
do you say that in French? 11.
Onze.
So onze.
Oh, you can do your French accent better now because of your...
Because I'm sick?
Onze.
Onze.
Yeah, that's good.
I hate it.
You don't have to put on the...
Continue.
Yeah,
just we don't need to... Come on.
So this thing is, I'm going to abbreviate it more, probability of lung given smoke.
I mean, you don't have lungs if you smoke.
And now we're going to divide both sides by 0.17.
Let me grab a calculator.
And 0.11 11 divided by 0.17 is going to be a little more than half, whatever it is.
64.7%.
So this is 64.7%.
It's in my face. But that's cool.
Sorry. So the probability of having lung problems, given that you are a smoker or somebody else, is about 64.7%.
Which is probably fairly accurate, but a large number.
Who knows?
CDC could tell you. They knows.
Yeah.
All right.
This is cool. This is way too hard for the SAT or ACT.
Yes, it is.
But I think it's exciting.
All right. I'm going to spray it down.
Yeah, spray it down. Mr. Brendan, tear this math problem down.
Move that bus. No? Okay.
I was doing...
Oh, yeah, you didn't watch TV.
I was doing Mr. Gorbachev tear down this wall.
SoHCA, you're new. Do you have access to Form 74H?
74H. Which
maybe?
month is that?
I mean, as much access as anyone, I guess. But do we have access to use it online? Probably. Maybe not. Probably not.
We don't put online the
anything
the
that's
non-official
not free.
ones that are free because
legal issues.
Of the people who would get in trouble quickly, we are earlier on that list than
you, but not by much.
You, not by much.
No idea. My tutor got it on crack SAT. Oh, you should probably not say that. They can get in big trouble for that.
Yeah. What's your tutor's name and email address?
Probably illegal? No. We just talked about probability. It is illegal. There's no probably. It is.
It is.
That's certainty, not probability. There's
okay.
A slight difference.
Do you
crack
have
ACT?
So
yeah.
We have not seen it, but
if you have a specific question from it, take a picture, send it to our Discord, which is linked down below.
Yeah.
And we can go over the problem. Like that is something we are totally allowed to do.
Or write out the problem by hand on a piece of paper, crumple it up, throw it in the garbage,
and then take a picture.
Yeah. Yay.
No, that's the official test. Can you send that to our Discord? I don't know if I want that on our Discord. Take a picture of the specific question. You can screenshot it. Or I guess we can look. Oh, yeah, no, we're not going to have that. QuantumACTprep.com.
Oh, they're just giving us a link to the
74H. 74H. What question?
Oh, 74H is from December 2016.
2016, maybe.
Oh, yeah, that's pretty old.
But what question ACT is hard? It can be. That's why you're here, to ask questions, and we can enlighten you on it. It's like any other test. It can be studied for.
Hard things are hard.
Like rocks in a hard place.
And stones.
Yes, thank you. Plaster Hippie, do you have a specific question from that test you would like us to go over in the next 3 to 4 minutes?
I forgot about quantum ACT prep. I haven't looked at that in a long time.
No, it's been a while.
Did they get in trouble?
Maybe. I don't know. Maybe
oh, no. They used to have the actual ACT test.
I mean, it would be easier if you could screenshot it and send it to our Discord. Or you could tell us the question number. And
you could just tell the question. That's fine. And
you can tell the question.
We can look if you are worried about that. Let me see what you're saying.
They only do. It's just a matter of effort.
Number 22, math?
Yeah, which one? There's 4 number 22s. There are. I think I might have said theirs. English. Ho ho ho. Levi.
I don't know if it's going to work.
Anglais.
No, it's not going to work.
It's not letting us open it or access it. So if you could just screenshot that specific question or that area, we can do it.
Let me just check our drive.
Okay. We might have it somewhere else. 74 H. Spanish, ladies and gentlemen. Beautiful language. Not like French.
Hey.
Yeah, I'm biased. What about it?
Yes, you are.
I know. Is Anglais French for English?
Anglais.
Or however you would pronounce that.
Yeah. Okay, so we don't have 74F. Sorry, and we don't have the account that
74H.
Quantum 74H.
That either.
So we cannot access that question.
But you can send us a screenshot.
If you know what it is,
whatever.
and you know what it hits on, and you know, like, is it semicolons? Then we can talk about semicolons.
Mm-hmm. One second.
What is that? Is it Thumper in some children's show?
That would be Bambi, but I don't know. I don't know if I ever saw that.
Yeah, Thumper who's waiting and just with the
yeah.
Thumper.
It's Eeyore. He's really? Oh,
yeah.
Energetic.
Yes, Eeyore is the most energetic of all children's animated characters.
I don't know. Winnie the Pooh's a close second.
Yes. Also, this information will be on the BPL subject test for the SAT, for those of you who are taking it in March. You should take it.
I don't know if you should fool the children like that.
We should.
I'd be nervous I couldn't pass it. That's the problem.
No, yeah.
I don't remember major
I would
life
definitely
events.
not pass LPL.
You don't remember anything about your life.
Exactly. Also, Plaster Hippie's doing that stuff. If anybody else has questions, Facebook people, is YouTube
We are also
working
about
tonight?
out of time. YouTube, YouTube's on tonight.
Okay. YouTube people, there aren't any of you. And then Twitch people.
Let's not say that on stream.
Right.
We talked. Yeah, okay,
Yes.
cool, good. Cut that out. Brady, cut it out.
Brady, cut it out.
Cut it. Cut it.
Snippy. Marker.
I practiced doing that like a whistling S.
Oh, the sibilant S. I think it's called the sibilant S. Sibilant S is...
I can make the whistle sound. It's just hard to make an S sound while I do it. Like,
yeah. Sylvia,
that's fine. That's easy.
Sam,
I heard something pop up.
Plaster Hippie.
Our Discord, Plaster Hippie, screenshot number 22. And we'll do it. We're going over time, but that's fine.
Oh, whatever.
Plaster Hippie posted a few.
Oh, yay.
Number 22 and then number 32. Let's do 22 first. Okay. For those of you watching, you can find it in our Discord, which is linked down below. Which of the following true statements, if added here, would provide the most logical link to the information about Leanne's work that follows in the next sentence? Okay, so let's think about it. The first sentence is, Lane convinced Nellie Orton, a tribal elder, who knew the language well but never spoke it in public, to be his teacher. So convinced Nellie Orton to be his teacher. Cool. He produced language CDs and created we would need the rest of that sentence. I'm sorry for that. I would need the rest of that sentence.
Well, there is another one. I don't know if that...
It's a different thing.
Oh, it's beforehand. Okay.
So we need to know what the next sentence is. And this is fine that you didn't send it just because it helps, right? You need to know the context. So I read the sentence before, and I want to read the sentence after because we're trying to link the two, right? So what information would most logically link what they had said before and the information that comes after? So he produced language CDs and created maybe an online thing. I don't know what it's actually saying here. But we want to link them, so we need to know the context of both. So the first one, and I'll go ahead and read through this. More than half of the Pacific Northwest, approximately 30 indigenous languages are already extinct. Without direct preservation efforts, more will be lost. I don't know how I like that. I mean, it could be valuable if it's something about the language CDs being there for storage. For the next 30 years, Lane recorded elder speech and studied the coastal Athabascan language, becoming one of the tribe's most fluent speakers. Maybe. It would, I mean, that is a timeline thing, so we could figure out after this if it's talking about a distance of that much time. It says, okay, so here's the sentence. He produced language CDs and created an online coastal Athabascan talking dictionary of words that has previously existed only in a few speakers' heads. Great. So it kind of is something I thought about. Just puts it online. So they get all this information together and puts it somewhere where it's easier. So, working with tribal elders, Lane helped design a cedar plank dance house along the Siletz River. That doesn't really connect the two. It's something kind of tangentially related. Lane also worked closely with two tribal elders, Lauren Bomelin and Gladys Bolton. He produced language CDs and created an online coastal talking dictionary of words. So, I actually like J right now, but more than half of the Northwestern indigenous languages are already extinct. Without direct preservation efforts, more will be lost. I also like F. I like both of these, right? Because it talks about how it's important to preserve them, and he's doing something to preserve them. So far, I like both of those. I don't know how I don't think I like B and C. I need to go back to the right question. So, for the next 30 years, they recorded the speech and studied the language, becoming one of the more fluent language or fluent speakers. I don't think that matters. I think that the first part of that is useful information, but to connect the two. But I don't think the fact that he became the most fluent has anything to do with him helping to create this dictionary. It is G. Which one is that?
Is it?
Is that the one I'm saying?
No.
I just don't like. They're saying it is G. I don't like that though. Because I don't think him becoming the most fluent is relevant. I think the first half of that is really helpful, but I don't think the last part is actually super relevant. Are you reading it?
Yeah, I don't like it.
I don't like it much. Is this the official test, or is that what this is?
The official test, yeah.
Man, they're going downhill fast. So he produced. So let's see. Lane convinced. Well, no, the first part is talking about having a tribal elder to be his teacher, right? So it's something about learning and working with them. Again. So okay, So F really works with the second half of this, right? So I was focusing. If you pay attention, I was focusing mostly on the second sentence because we didn't have it at first, which is a mistake to only think about that one. Fair enough. F I don't like after reading the whole thing because it only talks about. It only really introduces the second sentence or the sentence that is already there that we're separating, but it doesn't really tie the first one into it. H. We'll get back to G in a second. H, with the other tribal members, Lane helped. Yeah, the Cedar Plank Dance House is not relevant at all, so we can cross that off. And J, worked closely with 2 other elders. I think that can also be useful. So, what between G and J is the difference, right? Because this is something that is, if they are true, what would provide the most logical link? All right? So I think in this one, the reason G is more logical than J, in my opinion, is because it gives you a time lapse of how long it would take to create what they do in the next sentence. Whereas J just says, he's also being taught by other people, which is like, great, okay, but I took some classes and I've studied with people, but that doesn't mean I'm working on something for 30 years.
Yeah. I think...
This is a rough question.
This is
Absolutely
a rough question.
It is.
I think maybe link is what you need here. And seeing it all together, this is the best link, as you were saying, that
if you look
them.
From both of them. Yeah, I focused a little bit too much on the second part of this.
Yeah, J says also, and that's not necessarily a great link. But yeah, this is a hard question for sure. I wonder how we would have done in this question if we had seen it just all together in one thing.
Hopefully better, but I don't know. I mean, it's hard to say.
Yep.
But yeah, I mean, we also have all the time in the world up here to do this, and yeah, it's not how it is on the test. But
True.
I would say you really want to think about time. Sorry. You really want to think about how it ties both of them together. I was focusing too much on the second half and not the first half, and that's really how you want to go about eliminating answer choices. So you want to, what I did also was trying to choose 3 wrong answers, so we just cut through them. And thank you for continuing to post questions, but we are out of time. They can cover those tomorrow if you're on stream. Let us know when you are, and we can go back through those questions.
Yep.
Does that make sense for 22, though? And does it make sense why my strategy was flawed given the circumstances?
Oh, that's not where I want that.
Cool. Great. You think so? Yeah.
Yeah, just tune in, say hi. We'll go back to those questions.
Yeah. It's a matter of also practicing it and practicing these questions.
Okay.
All right. We are out of time. Thanks for joining, guys. We'll see you tomorrow. I won't. I'm going to be gone. But they'll see you tomorrow.
I will see you tomorrow. I'm going to be late again tomorrow.
Boo.
Oh, wait. Maybe not. Maybe not. My student doesn't need help.
Okay.
So it's fine. Yeah.
All right.
Good night.